Fermentation is one of those words we hear all the time, but rarely stop to think about. Yogurt, bread, kimchi, soy sauce, coffee, chocolate, wine. These everyday foods all have one thing in common. They exist because something microscopic was allowed to take control. Fermentation isn't cooking, and it isn't spoilage either. It's a strange middle ground where food is technically breaking down, yet becoming better, safer, and more flavorful in the process. So today, let's answer the question, how does fermentation actually work? And understand what the process really is. We need to zoom in, way in, to a world ruled by microbes. Let's get into it, right here, on History of Simple Things. At its core, fermentation is a process where microorganisms, usually bacteria or yeast, consume sugars and convert them into other substances. These substances can be acids, alcohol, or gases, depending on the microbe involved. Unlike burning fuel or using oxygen like we do when we breathe, fermentation happens without oxygen. That detail matters because it forces microbes to use a different kind of metabolism to survive. Think of fermentation as microbes looking for energy in a low-oxygen environment. They grab sugars, break them apart, and dump the leftovers back into the food. Those leftovers, like lactic acid, alcohol, and carbon dioxide, are what change the food's taste, texture, and smell. Not all microbes ferment food the same way. Yeast and bacteria play very different roles, and understanding them makes fermentation feel far less mysterious. Yeast are single-celled fungi. They're best known for making bread rise and turning grape juice into wine. When yeast eat sugar, they produce alcohol and carbon dioxide. The alcohol stays in the food or drink, while the gas creates bubbles or causes dough to expand. Bacteria, on the other hand, are responsible for most sour and tangy fermented foods. Lactic acid bacteria, found naturally on vegetables, milk, and even your skin, convert sugars into lactic acid. This acid is what gives yogurt its bite, sauerkraut its tang, and kimchi its punch. The key idea here is that fermentation isn't random decay. It's a controlled takeover by specific microbes that are better at surviving in certain conditions than harmful ones. Here's something counterintuitive. Fermentation actually makes food safer to eat. When microbes produce acids or alcohol, they lower the pH or create an environment hostile to dangerous bacteria. Most harmful microbes simply can't survive in highly acidic or alcoholic conditions. This is why fermented foods were vital before refrigeration existed. Vegetables that would rot in days could last for months once fermented. Milk that would spoil quickly could become yogurt or cheese. Fermentation doesn't stop time, but it slows decay by crowding out the wrong microbes and letting the right ones dominate. Sugar is the engine of fermentation. Without it, microbes have nothing to eat. But sugar doesn't always mean sweetness. In vegetables, sugar is locked inside complex carbohydrates. In grains, it's trapped in starch. Fermentation often begins only after enzymes break these compounds into simpler sugars. In bread making, enzymes in flour convert starch into sugar before yeast can even get started. In fermented vegetables, naturally occurring sugars slowly leak out as salt draws moisture from the plant cells. Once sugar is available, microbes move in. The amount and type of sugar determine how fermentation behaves. More sugar can mean more alcohol or more acid. Less sugar means a slower, gentler fermentation. Salt plays a surprisingly powerful role in fermentation, especially for vegetables. It doesn't just add flavor, it controls which microbes get to survive. Salt pulls water out of vegetables, creating a briny environment. Harmful bacteria struggle in this salty world, but lactic acid bacteria thrive. This selective pressure is what makes fermentation predictable. You're not inviting every microbe, you're setting rules. Only the right ones can follow them. Salt also slows fermentation, which prevents things from getting out of control. Too fast and flavors become harsh. Too slow and spoilage can creep in. Salt keeps everything balanced. Oxygen changes everything. Some fermentation processes want it, others absolutely don't. Yeast behave differently when oxygen is present. With oxygen, yeast focus on growth. Without it, they switch to fermentation and produce alcohol. That's why wine fermentation happens in sealed containers, while sourdough starters are left open to the air. Lactic acid bacteria usually prefer low-oxygen environments, which is why fermented vegetables are submerged under brine. Managing oxygen isn't about perfection, it's about direction. Fermentation works because the environment nudges microbes toward the behavior we want. Fermented foods often taste deep or rich, even when they contain simple ingredients. That's because fermentation creates hundreds of new compounds. Acids, esters, alcohols, and amino acids all interact on your tongue. Proteins break into amino acids, enhancing savory flavors. Sugars transform into tangy or slightly sweet notes. Even bitterness can soften or become more rounded. Fermentation doesn't just add flavor, it rearranges it. This complexity is why fermented foods often feel satisfying in a way fresh foods don't. There's more going on, chemically and sensorially. People fermented food thousands of years before anyone knew what bacteria were. They didn't understand microbes, but they understood patterns. Food stored in certain ways lasted longer. Certain smells meant safety. Certain techniques worked again and again. Fermentation is one of humanity's earliest experiments in biology, even if we didn't realize it at the time. It's knowledge passed down through habit, not textbooks. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.